I'm told that David West blew you all away, and that's going to be a hard act to follow, so thank you very much. And so I'm going to be talking about refactoring to deeper insight. I was involved over the last couple of years with a system called Nexia. It's a system in the United States. It's an Internet of Things application, and what Nexia allows you to do is automate the devices in your home. So you can control your thermostats, you can basically do any number of things. I thought I had video footage of that. Yes, there we go. So you can control the lights, you control garage door, read your thermostat. If I had Nexia on my phone right now, and I could show you that I'd be able to query the status of all the doors in my house and see if they're locked, that type of thing. So it's an Internet of Things application, and it also supports webcams. And so not only can you turn on lights on and off, but you can actually set up cameras within your home and be able to view those cameras from anywhere in the world, right? So it's funny because every video that shows this really creepy scene of someone looking at their kids like while they're doing their homework. I don't understand why that is. And so the project I was involved with, Nexia has been around, I think, since 2009. So it's actually a very mature application. It's a mixture of Rails and Java. And I was brought on to help them with some design challenges they were facing. And it was really great to be able to work with them. And I want to do a shout out to the Nexia team because they gave me permission to talk about their application, to show code, and to share with you what we learned through the process of improving the camera support within Nexia. So what we found was that the camera support within Nexia is very, very good from an operational perspective, but from the perspective of being able to add support for new cameras, with new models of cameras within Nexia and get those out to market more quickly, that was a bit of a struggle. And so let me show you a demo of what it looks like to use Nexia. So this is, if you imagine a homeowner is adding a new camera that they've just purchased to their system. So they can go to the video option here and select to add a device. And then they choose the device to enroll. So notice we're using the word enroll here for a camera. They get the instructions for that. They can see a video of that if they want to watch that. And then they enter in their Mac ID, just like that. And then we can see we get a message saying that the camera is activating. Nexia is actually connecting to the camera over the internet and establishing the protocols. We can give it a name, in this case, Dan's new camera. So Dan Sharp is actually the software architect for the Nexia team, and he and I worked on this together. So everything I'm going to show you, for the most part, was pair programmed with Dan. And there we are. So we had just set up that camera. There's Dan. And give Dan a round of applause, because he's not here. And so that's the process for setting up a camera, right? Enrolling a camera. Now, that was what the user sees. Now let me do like a very high-level architectural overview of what that looks like. But this is actually an architectural overview, not of enrolling a new camera, but imagine now that the camera is already enrolled, so Nexia already knows it exists. And now we're going to walk through what happens when a camera is turned on that Nexia knows about and it connects to there. So this is Dan's hand, the hand of Dan. And so here's our webcam, and you can see it's not just one camera in a house, it's actually many cameras, right? But it's actually not just one house, it's thousands of homes. So it's actually tens of thousands of cameras that are connecting via SSL to a component that's called the camera manager. And not just one camera manager, but many camera managers, because there are many, many requests coming through. It's SSL over HTTP. And the camera manager is written in Java, and it's deployed out to servers that are dedicated for that. What happens is when those requests come in, they get enqueued onto a jobs queue, and so then we're able to read off that queue. So this is, notice, distributed, asynchronous connections, and it actually connects to what we call the portal, which is actually a Rails application running workers written in Ruby. Okay, so we've got multiple languages, we've got a distributed system. It's built for scale to be able to handle many, many, many concurrent asynchronous connections between all these cameras. And then once that connection message comes through, then we have a message bus that, of course, doesn't really look like a bus, it looks like a tube. I'm not sure why jobs look like that and a bus looks like that, but that's what it is. So the message then comes back to the camera manager, and that's the whole process of a camera going through that connection and sending a message back to be able to now we can control the camera. Okay? So that's just at a very high level, that's the layout of things. And the reason why this is important is because what I'm going to do is talk through those various components. So this is the layout of the Rails app. If you've done any kind of Rails development, it'll look very, very familiar. We've got controllers, we've got models. And what I've done is highlighted just the ones that we care about. So there's a cameras controller, there's a camera model, there's camera activation model, and then there's a bunch of workers for things like activation and camera worker for handling the general operations that go on with cameras. And as I said, this is all in Ruby. So this all sounds good so far, so let's talk about some of the challenges that we were up against. The first one is that the code was very hard to reason about. So this is an application that had been around for a long time. A lot of contractors working on this application since 2009. And the Java Camera Manager, basically there's a device manager that controls all these other things like thermostats, and Camera Manager was kind of cloned, if you like, out of that, like it was derived from the more general device manager. But then it was extended and designed to be this meta framework for cameras. And so what happened was that we found that there were a lot of abstraction layers inside this camera manager, and it was very hard to, it felt very cluttered and unwieldy. And I'm not going to show you all of that, it's very hard to give a sense of that, but I'll try and give you a sense of that. So this is a method called handle request that handles the requests that originate from the camera. So when the camera sends Nexia a message over HTTP, what does that look like? So let's just walk through it. So this is the first time you've ever seen this code, probably. Imagine you're looking at this for the very first time. What questions come to your mind? Well, let me think. What is a zombie? Right? What on earth is that? What does that mean? How could a camera be a zombie? That's probably the first thing that comes to my mind. Maybe that's important, maybe it's not. And then there's some other confusing things here. So notice there's an if clause right after that if is zombie, and it says if authorized, is authorized, right? But then the very next comment says, we're not currently authenticated. So is that a lie? Are we talking about authentication or are we talking about authorization? Because are they the same thing? Of course not, right? So ubiquitous language. And then further down we've got auth. So when it talks about auth, is it talking about authentication or is it talking about authorization? Very, very confusing. And then we've got all these things, these lines of code that really seem to be concerned with is getting a key. But what do we use the key for? And then we're setting options further down. And this is just a very small sample of some very confusing cluttered code. If we look on the Ruby side, in the workers there, what had happened in there is that the camera support had grown over many, many years. And this is probably a common situation for you. You have contractors kind of coming on the team, they do some work in an area, and then they move on, and then other people come on. And so it was never actually, you get this sense when you read the code that this was not purposefully modeled, this is just kind of accreted over time. And there were lots and lots of responsibilities in strange places and all muddled together. So let's look at an example of that. So this is the camera worker. It's responsible for authenticating and closing those camera connections and being aware of that on the Ruby side. So we have a camera auth method, and the very first thing it says is if camera. And then if camera is allowed to connect, so far so good, right? This is Ruby code, it's quite readable. And then there's a bunch of code that's commented out, there's comments there, and then it grabs a key. But then the comment talks about a Moshi key, but what is a Moshi key? And then it sends an authentication to the camera, so that seems okay. But it goes on. This is Ruby, and yet it goes on. So now we talk about if it needs a reboot and what's going on there. We've got event publishing happening. But then what's going on now, it looks like we're actually going inside this new camera object and starting to set all its properties from the worker. Right? So the worker knows everything about the internals of this camera object. right? We're doing open surgery on this camera. So we're setting a model, the firmware version, we're telling it it's connected, and then further down, it says camera.startMotion. So are we actually starting the motion on the camera? What we found was, no, that's actually telling the camera that start motion is available, I think. Like it's still, there's some confusing stuff, but it goes on, right? So if the house is defined for this camera, then we do the same sort of thing all over again with a whole bunch of other different rules around the camera. And more camera surgery, but it goes on, there's more, right? So this is this one method that's 136 lines in Ruby that does all this kind of stuff. And I look at that from a DDD perspective and think, I think some of these responsibilities would be better served moved somewhere else, right? So that was problem number one. Problem number two is the camera manager was overly coupled to device manager, and this is far more of a technical kind of issue. So I'm talking about the Java side of things. Basically, because it had grown out of device manager, it was actually, it had a link in the class paths with the device manager, and so this function in DDD terms is a shared kernel with the rest of Nexia. So we couldn't upgrade Java because we couldn't upgrade Java. We'd have to, it's like that joke that Joe Armstrong tells, you want a banana, but you get the gorilla holding the banana and the whole jungle as well, right? This sort of feels like that. So it's a significant deployment issue here. We just wanted the banana, but we get all this other baggage because of this shared kernel and this tight coupling. The other thing is, and this is more my DDD accent coming out, is that the domain knowledge seemed to be in the wrong place. So camera manager should really be about managing camera sessions and not much else. Are the cameras there? What's going on with the sessions? That type of thing. But it seemed to have a lot more responsibilities. It knew a lot more. So if we look at the Java side of things, what we found was anytime we wanted to add a new feature for a particular camera, like, oh, this camera needs to support pan tilt or zoom or something like that, it took a long time because we had to deal with all these abstraction layers. It was very complex, and that code smell of shotgun surgery. You have to change a bunch of things in a whole bunch of different places to enable that. So here's an example, the start motion. So we want to be able to enable and configure motion detection and reporting on the camera manager. So I'm not going to walk through this in too much detail, but you can see we're building up we're setting a whole bunch of messages to the camera, right? All these HTTP messages calling these different URLs. And some of this code, I should say, is sanitized. And then we've got all this pattern matching down there, and it goes on, and then we build up this entire kind of key value store, and then we send that to the camera. It's very, very hard to understand why all this deep information about the way the camera worked was embedded in something that seemed like it should be just managing camera sessions, right? And it made it very hard to do that. It goes on. Now we're setting up things like the frame rate. So this one's kind of cool. Like apparently the quality level, whatever that means, can't be 1 or 2. 4 is right out of the question. It has to be exactly 3. Who knows why, right? These types of things. And that long, long list of parameters, what does that mean, right? So there's all this knowledge embedded in the Java code in strings and things like that that made it very hard to know what was going on. So what about on the Ruby side in terms of domain knowledge? Let's look at the start motion method in the camera object. So we have start motion, and then the camera, we run a method, is the camera outdoor, and then we set all these options in the Ruby code as well to do start motion. So here's the question. You're a developer, you come on this team, you need to set up a new capability on a camera. What do you have to touch? All these different places, right? And once again, we've got magic numbers in there. We don't know what these things mean. It's very hard to reason about it. Apparently, we've got a local URL embedded in there for testing purposes. I don't know if you noticed that or not, but this might look very familiar to the type of code that you come across in your system, right? And it goes on. We've got other camera options that are embedded there. So, I'm just feeling exhausted. Like, this brings back memories. Okay, so let's back away from that a little bit and think from a DDD perspective. So what kind of concerns are you noticing? I'm sure you are, because normally in the past when I've given this talk, it's been to people that are unfamiliar with domain-driven design, and part of it is explaining why these things matter, but I don't think I need to do that here. Number one is I want to grow and express a deep domain model in the code, right? But this is a Rails application. How do I do that? Secondly, I want to be able to refactor towards ubiquitous language in the code, right? And that's an important concern for this, is what is the ubiquitous language? So words like zombie and authentication and authorization, they may not seem like important terms, but they really are. If you don't understand what they mean, how can you work with this system? And then I really want to have clearly delineated module and boundary responsibilities, okay? I want to have good boundaries around things and clear responsibilities for components, right? And these are not just DDD concerns, obviously. These are just general design concerns like Rebecca was talking about this morning, but they're really significantly important. So where to start? What do you do when you come into a code base and it just feels overwhelming? Tests, talk to the people, these are all things, but it can still feel overwhelming. Like, how do you know where to start, right? I heard a story years ago about this girl, and she's walking along this beach, and the beach is covered in all these starfish, like first thing in the morning, and she starts picking up the starfish and throwing them back in the water to save them, and someone comes up to her and says, "Why are you bothering doing that? You know, doesn't make a difference. Look at all these starfish that are still here." And she picks up another starfish and she throws it in the water and says, "Well, it made a difference for that one." Right? So I want you to think about the starfish principle here, is just because you can't fix everything and it can feel overwhelming doesn't mean that you can't make some kind of small improvement that can make a difference, right? Because that's a key thing, is that feeling of getting up in the morning and going to a hard to maintain code base, and it can start to feel like drudgery, but we need to remind ourselves that we're people and we want to do good work and we want to reduce the clutter. So what we did was we decided to take a baby step in March 2014. So we looked at our options and said, well, what can we do? So what we had was this theory that we wanted to prove, that the concept of a camera is actually two distinct responsibilities. The first one is the concept of a camera is, and this is probably how you mostly think about the concept of a camera, is it's a stateful representation of a physical device. It's what is the state of the camera right now? What is the camera actually doing? And then the second thing is, so that's seeing camera as a thing, and this one is seeing camera as something that you can interact with, right? And focusing on the interaction and sending commands and queries to that physical device. So first one is almost like camera as a noun, and the second one is camera as a verb and what we can do with that. So then once we had the idea of these different responsibilities, we started saying, well, what could we do? Well, what we noticed on the Ruby side was that both of these responsibilities are in the camera model object in Ruby, which subclasses device. Now, device is used to also represent things like thermostats and garage door openers and locks. And those physical devices have completely different behavior from a camera, right? You don't tell your lock to stop motion, right? You don't zoom in on your window lock, you know, those types of things. And so what we found was this camera object was huge in Ruby. It was one big God object because it just had all this baggage. So what we decided to do was we decided to add a new domain service. So we added a command service on the Ruby side, and we decided that let's put all the interactions in there and start to narrow down the focus of the camera object on just state more than anything. So let's have a command service on the Ruby side that's responsible for talking to the camera manager on the Java side, which is going to interact with the camera. Now, here's the cool thing about this. We pair programmed on all of this. We drove it out with TDD, test first, and we were actually doing a lot of this pair programming using Screen Hero and Skype remotely, which I highly recommend if you need to do remote pairing. And having that continuous conversation around how are we doing this? What responsibilities do we need to move out as we go along? And then the thing that was great on the Ruby side is we already had a really good test suite, both on the Ruby side and the Java side, that allowed us, that covered controllers, workers, and other collaborators, at least a test suite more at the integration level that we could lean on for this type of work. But we weren't actually, so we did that, and that in itself was a huge improvement for us to be able to do that. But then we did some event storming, And there's Dan explaining some of what we did. The event storming here was comparing the enrollment process between different categories of devices and how they differed. So we decided to look at the camera manager and see, well, what could we do on that side? Like I mentioned, it has too many smarts. It was doing too many things. It really should be just about managing camera sessions. So Michael Feathers talks about finding a seam, something that you can insert new behavior into and build on that. So what we decided to do was to take the camera manager and add a new method that would make it just a generic HTTP proxy, so it doesn't know anything about the contents of the commands, it's just passing them on to the camera as kind of a broker or a proxy. And so all the commands become HTTP calls. So we wanted to focus it on these concerns. Being a generic connection proxy meant we wanted to focus on connection management, authentication, and the messaging between the portal and the camera. So simplify it dramatically down to just the essence of what it means to be a generic connection proxy, right? Simplify its responsibilities. And then the last thing from a perspective of this is a large-scale Rails application running tens of thousands of concurrent camera sessions is we want to be able to have good logging around this so we can keep track of problems as they emerge. So what was the seam? We introduced a new generic command on the camera manager side. And it was just very simple, a generic send URL command inside the camera manager that would basically take a URL from the Ruby side and pass it through to the camera without really knowing much about the content. So now what we could do, so think about this, now what we could do is format the command on the Ruby side, send it through to the camera manager, and the camera manager as the proxy would just pass it through to the camera without having to know any new internals. And we could use our Ruby side new camera service to be able to do this all in a completely additive way. So on the Ruby side, like I mentioned, we use the command service combined with end-to-end local environment to send arbitrary commands to the camera. So all of this is still in development. One of the things that you need to be aware of with this type of system is that if the camera managers ever go down because we have to redeploy, that'll disconnect every single camera. And then they'll all, after a certain period of time, they'll all reconnect and start trying to poll the camera manager. And so we have to be very, very careful about bringing those camera managers down because we don't want a thundering herd of connections to be coming in. So there's a very important runtime concern here. So we decided to, in the process of doing this, what we're really doing is migrating that domain logic from the Java side in the camera manager to the Ruby side with the camera command service. So not because we had anything against Java. It's not really the language that I want to emphasize here. It's where should the responsibilities be in these components? Where should the smarts be? So the approach is that we want to move those things across from one to the other. So what we did is one at a time, TDD'd, moving commands like pan tilt over to this generic camera manager interface. This was an internal refactor. The key thing here is that the calling code did not change. So what this meant is we weren't breaking anything, like we weren't changing the existing code. This was purely additive. So we got some early wins from that once we added some of these things in. Like we hadn't even deployed it to production yet, and the support team was able to use this. Like we rolled out at least that part of the functionality, and now the support team was actually able to get into a Ruby console in IRB and start sending generic commands to users' cameras to troubleshoot problems on their cameras in production. That was incredible. They'd never had that ability before. Before, we were locked into only what the Java code provided. The other thing we were able to do with this was we were able to perform a bulk upgrade of the firmware on the installed cameras using the same kind of technique from the Ruby side. And then from our perspective as developers, what this allowed us to do now is we could, in Ruby and IRB, construct arbitrary commands and send them through to a camera. And so one of the things I want you to see here is this is a tiny change. But what it allowed us to do was to shorten our feedback loop down to something we never had before. So I don't want you to undervalue. You need to value shortening feedback loops, right? And if you're looking for early places to start, being able to experiment more quickly is a win. So one of the things I want to emphasize here is when you're doing these types of refactorings, and this really was a refactoring, we weren't building new functionality at this point, is to get buy-in, you need to have some early wins. I see a lot of development teams that they say, well, I want to spend a day cleaning up this code or a few days, but I have a lot of trouble justifying that effort. Well, if you're in that type of culture, then try to do that work, that design work, in such a way that you can demonstrate some wins, because as we say, it builds trust, credibility, and momentum here. It's not always the case that you can find them, but look for them. Because if you don't look for them, it's unlikely that you'll find them. You won't stumble across them. So then we looked at the camera and the workers cleanup to see what we could do on the Ruby side in terms of cleanup. What we saw was that in terms of authentication, so authentication being, is this a camera that Nexia knows about? There were three kind of things that were going on. We needed to authenticate an existing camera, so one that Nexia has connected with in the past and it's reconnecting. And then we needed to be able to, when a home user, a customer, adds a new camera to their home network, we needed to be able to create and authenticate that through that enrollment process that I showed you right at the beginning. And then we need to be able to handle zombies. And the actual rule for a zombie is that it's a camera that is connecting, so it's sending messages to Nexia, but Nexia no one's gone through that enrollment process. So as far as Nexia is concerned, it's a zombie camera because it's trying to eat us, but we don't want to have anything to do with it, right? So we looked at the camera worker and we said there are actually three distinct aspects of authentication, and we refactored those out into authenticate camera session, activate camera session, zombify camera session. Right? We took that behavior and we moved it out of there, inside the camera worker. And then in the old camera code, like this is from the camera model code in Ruby. So you can see there's a lot of logic there around, so this example is a firmware update. What do I need to do for a firmware update? And you look at this code, so what does it mean that model is nil? Right? What does that mean? And then if the firmware version is nil. And then we've got this whole thing around if the model number is present, then what's going on there? And there's a lot of comments there that we need to describe that. And then you can see there's some sort of string manipulation there that we have to do to figure out, should we upgrade does it need a firmware update or not? So we refactored it to this. Ubiquitous language in the code. So if the model is present in the information we get from the camera, and there's a recommended version, firmware version for this camera, and that's present, and the firmware upgrade is not already in process, and the firmware is old, we need a firmware upgrade. Okay? That was a very straightforward refactoring in terms of that other code, but now I know the intention. I can reason about this code. And that was not a hard refactoring to do. But this is the type of thing that we have opportunities to do these types of things in the code, like the starfish principle once again. So one of the things I want to emphasize here, and maybe this seems a little bit simplistic, but bear with me for a second. One of the things that I did in that camera model class in Ruby was Dan and I sat there and we just started moving code around, just rearranging code, because it felt like this overwhelming sense of clutter in this giant class. And like, I've had this experience. I have a home office, and on Saturday I'll come back from this trip and I'll just dump everything in my office and crawl into bed. And then on Monday I wake up and I walk into my office, and now it's like there's the clutter that I didn't clean before I went on the trip, and now there's even more clutter, right? Does it ever feel like that when you get to your code base in the morning? It's like, oh boy, okay. Sometimes just rearranging code can be a powerful design technique, where you're not even changing the code, you're just rearranging it. It's that process of, like, if you ever write a blog post or anything like that, it's that process of just moving thoughts around to look for patterns, to see areas where there's commonality. So don't undervalue the importance of just rearranging code when you have overwhelming clutter. So one of the things we started doing was we started making the camera more aware of what its capabilities were. So does it support high definition? Does it support low res? Is it an indoor camera? Is it an outdoor camera? So we could ask the camera questions about itself without having to dig inside the internals of the camera. We also did things like in the camera worker on the Ruby side. Remember that code I showed you right at the beginning of we're doing camera surgery? Well, what does that look like to you? What is that? What's the design pattern we could use there? Factory, builder, right? We're building something, right? We can use a factory or a builder to do that. So we created 2 new methods on camera. We created an update from heartbeat method. So when a camera reconnects, which is called a heartbeat, we created a new method because the camera, something may have changed on the camera that we need to know about. And so we get the message from the camera and then we update from the heartbeat. Or maybe it's a completely new camera that's going through that enrollment process, so we have a create from heartbeat method. And now the calling code becomes, like all that goes away out of that camera worker now. And then on the Java side, we stripped out all the commands and removed the domain logic. So we just have a message like portal message received. We got something from the portal. And if it's a camera command, handle the command for the camera. Otherwise, handle the command for the server. The Java code goes, nice, right? And at this point, we still haven't deleted code in production. I want you to understand that. So the old Java code looked like this. I showed you that at the beginning. This is the new code. If it's authenticated, send the privacy status to the portal. Otherwise, if it's a zombie, handle the heartbeat. We've got a heartbeat, but it's not authenticated. Done. So just to step back from this for a moment, in the face of overwhelming clutter and complexity, you can feel like you're in a fog. You come into the office in the morning and you start working, and it's really hard to get clarity. But by starting to move forward and clear away some of that fog, it opens up new insights. I think when Eric coined that phrase, of refactoring to deeper insight, that's what it's really like. There are things that you learn that you can only learn if you put the time into doing refactoring, because refactoring opens up new opportunities. So when you are in the face of this kind of fog, you need to be able to persevere and stick with it and push through to that clarity. So on the Ruby side, I mentioned that we added the command pattern for camera commands. And so what we have here is we created new command objects. So every command that could be sent to a camera, we looked at that and we're like, you know, here's an opportunity. Instead of just having a smorgasbord of methods inside this thing, why don't we refactor to a command pattern? And then we have all these objects, like configure prebuffer now is actually an object. And we can then have a generic command handler inside of the command service that basically just executes commands now. It just simplifies the whole thing down, and the actual details of what's in that command end up in those command objects. Once again, this opportunity was not clear to us until we did this other cleanup work. The other thing that was really cool, and this was Dan's idea, was to put in a feature toggle. So what he did was he actually figured out a way of being able to know what kind of messages were being passed around and handle them differently depending on what version they were dealing with. And then you'll see right down the bottom there, notice to do. What's the to do? Delete this legacy method. So once we've proven out that this thing works right across the entire camera platform, then that's the code that we're going to get rid of. So what this allowed us to do is we've got the old structure in Rails there of what it looked like, and you can see on the new one that we touched camera RB, which is in the models folder, so that's the camera model. And remember we said we were focusing that on the state of the camera, and then all the responsibilities for talking to the camera were moved into the services. So the commands, like command authenticate, and then we had the command service, which was the legacy one that we were eventually going to change. And then we've got the workers for things. We've got like legacy auth handler there as well. So we actually changed the folder structure to indicate what things we needed to remove. We then did a phased rollout. So in the first month, so very late in the first month, we did a limited rollout to Nexia internal IPs. And the audience for that was really just the QA staff and dev and support, and it was on a single production server, so that we were able to test it and see, is this working the way we want it to? And then in the second month, what we did was we rolled it out to internal IPs and to the load balancing section, and that was to select customers, right? So this is like a portion of our customer base to a single production server. Remember what I said was that we want to limit the impact to our customers. And then early in the third month, we rolled it out to all cameras. And it was actually very, very successful. We had a few minor problems, but by and large, it went very, very smoothly in terms of that. So one of the things that I noticed, because I'd never really used a feature toggle like this before in the context of a phased rollout, was that what a feature toggle allows you to do, I think, is it creates the ability to defer decisions, right? In lean software development, they talk about defer commitment, right, as a lean discipline. Being able to, in the real options literature, they talk about creating options and that options have value. Colloquially, we would say, keep your options open, right? Feature toggles are a way of doing that. Feature toggles and phase rollouts create options, and from if you read the book Commitment, the graphic novel Commitment, it talks about options have value, and you shouldn't destroy options unless you know why you're destroying those options. And that options are an important thing, right? So what were the next steps after that? Now it was in production, it was being used, it generally went very well. Well, we removed the feature toggle. Oh, happy day, right? There's the commit, and then we tested that, rolled that out into production as well. I mean, that's got to be a good day, right? You come into the office and you're like, all right, here we go. Friday afternoon, done, right? And the thing that's comforting about this is we're not removing a single line of code that's being used. Like, every single line of code we're removing is actually not being used in production right now, all right? It's a good day. So what opportunities did that open up for us? Well, some other things that we considered at that point, well, maybe we can encapsulate the camera further. So maybe we can actually take this camera object, which is still a little bloated, and we can start doing things like taking features, state, variance amongst the models, because Nexia supports a wide variety of camera models, indoor, outdoor, wired, Wi-Fi. And there's lots of variance between those in terms of the state, the capabilities, and the firmware versions and all of that. So this opened up the opportunity for us to be able to move those things out. And then another thing was, instead of having all this complex conditional logic, like if this camera model, then do this, then we looked at maybe we could refactor some more commands to do this. Now, this didn't actually move on. We moved on to other priorities, but these are still options available should we come back to the camera work. So I want to talk a little bit about wins. I mean, this is still a challenging thing. Actually, before I talk about wins and these options here, I want to mention that, like going back to that video of the fog dissipating, it's very easy for me now to look back on that and think we were really clever, right? That we were able to figure all that stuff out. But on any given day, it didn't feel like that. We felt like we were pushing through the fog, and we weren't really sure if we were making the right decisions. And sometimes we went down a path and said, you know what, that's actually not the right way to go. We learned a bit, let's go this other way. So in hindsight, it all looks very clear and simple, but being in the process, it actually felt a little sometimes chaotic and messy, and we were unsure of ourselves. So if you if you ever feel that, like, just take a deep breath. It's okay, because you can push through it. So what are some wins? Well, before, adding a new camera took months. Supporting all the camera models, touching everything, dealing with the deployment issues, and we had to change the things on the Java and the Ruby side, and it was very inconsistent where do we put things. It was very hard to reason about, like I said. Now, a new camera can be implemented in months. So next year, a new camera comes out, and it can be supported, in hours, not months. I need to read my own slides. So we can actually take this ability to incorporate new hardware into Nexia from months to do that down to less than a day. Right? That's a win. Then another win is that this is mostly a Ruby development team. So we don't have to touch the Java code anymore. We've simplified that down, and we only need to change things on the Java side. We do a redeploy, and it's done. We don't have to deal with those issues with the Java version anymore. And then I think for me, as a software designer, as a software remodeler, being able to have cohesive code now, code that I can reason about, in some areas where it's important, is a big win as well from a development perspective. So, easy to read about, reason about, contexts are clear. And the other thing we were able to do is to take that dependency between the camera manager and the device manager and eliminate that because we simplified it down. We focus the camera manager on things that are only concerned with cameras. And that's the talk. Thank you. I think we have time.
Oh, we have plenty of time for questions, so please.
Yo.
Hello.
So I've got a couple of questions.
Uh-huh.
And the first one is, how did you choose which refactoring to perform? Because I can imagine that, yeah, you being a great DDD designer could have seen a lot of refactorings there. And then how did you choose which one?
So yes, you're asking me to introspect on how I make those kinds of decisions. That's a great question. What we started with was, like I mentioned, it was a baby step. It was, let's choose something that is small and simple, that doesn't involve a lot of code changes, but it's the minimum amount of effort for the maximum amount of learning, I think was what I was looking for, was return on investment in terms of I'm going to change some code, see what happens, and then see what I learn from that. Because I'm not ready yet to make a commitment as to what this large refactoring might be. So I'm going to take a step, do a bit of experimentation, and then step back and say, okay, what did I learn from that? And I may have created the impression in the way I presented it, that it was like, okay, this is the step to take, and here we are, and we made the change. But it was actually a little bit more like blundering around, trying a few things. And so for me, I think a little bit of experimentation and tinkering is part of this, and trying something. So Dan and I discussed a lot of options and disagreed on things, and sometimes we tried both. To see, it's like, okay, we've got a couple of options. Okay, well, let's spend half a day on this one, half a day on this one, and at the end of the day, let's compare and see what that might be. Or maybe it was just an hour on this one and an hour on this one, and then let's compare them. So it was really kind of that whole scientific method of, we've got a hypothesis about what might be the best thing, so let's do a little bit of experimentation, and then let's see what we observe from that.
Okay, cool.
Good question, thank you.
Can I ask a question?
Oh, I like that you just...
Yeah.
Okay.
An important refactoring you didn't do was, did you end up renaming the camera manager to something more telling, more limited?
That's an example, yeah, so that's an example of refactoring that would have been nice, but we never got there. So there's still, I think about this code base, I picture it in my mind, I think there's still like 1,000 things that I could do on this code base, right? And that would be near the top of the list, but it's still not there, right? Like anytime you see the word something manager,
yeah,
it's a bit of a weasel word, right? It's like, so a better name would have been good, but that's kind of what it was it's the whole thing of we have this weight of coding history that's bearing down on us. And so because we had a device manager, what do you think they chose the camera thing to be? Well, it's the camera manager,
yeah,
right?
Of course.
Yeah, so that's why. Good question. Okay, next question.
Yeah, and the H.264 quality parameter you talked about, it's there because mobile devices only support 3. If you need to refactor that.
Okay, send Dan your email address, that he might want to talk to you. Nexia is hiring.
So I have some painful experiences with active record-based frameworks and legacy applications.
Me too. We can do a support group later.
Yeah, and well, the most painful thing was always that you want to do refactors that are very difficult because of an inherent coupling with the schema and with presentation. How do you cope with this? I mean, you were fiddling around with the camera thing, which is probably has ties into the schema and to
absolutely
a lot of other things. Didn't it ripple through the whole system? And
no. No, I mean, we're talking 400 model files at least in this application. It's a large Rails application. And so we didn't change the database schema. What we did was we separated the responsibility, we moved the responsibilities around. So we focused that Ruby object on state, that active record object on state. Now we could have gone a different way, but that's what we decided to do. And it was an improvement. So I see some questions down the front here, I think. So, all right.
Well, it seemed very developer-driven.
Yes.
Did you have access to and use domain experts while refactoring to deeper insight?
Yes.
And did you do it deliberately or?
Yes.
Okay, thank you. That answers my question.
I'll give you a little bit more nuanced answer than that. So this is an Internet of Things application. There was no value in us going into somebody's house and saying, tell me how your camera works, right? The type of domain expertise we needed was things like what HTTP commands does this camera support and what kinds of things. So we spent a lot of time interacting with the people that have built the firmware for the cameras around that. And then in terms of domain experts, Dan really was the domain expert in this situation, right? Because it's a highly technical domain. And that's one of the things that really intrigued me about this project was that it's one of those rare situations where the developers really do have to become the domain experts, right? In most cases, that's not the situation. In most cases, you're working in the context of finance or something else where the knowledge of the business is not in the developers' minds, not to start with anyway. So Dan had been with the team for 4 years, I think, at this point, and so built up a vast amount of knowledge around this. Okay, so good question.
Hi. You came in as a consultant, worked with one of the developers in a small setting on a large code base with a larger team. Were the changes you were doing having a visible positive effect on the way the other developers were working?
Well, we walked through, so that photo I showed of the event storming session, that was actually Dan walking the rest of the team through that. Did the entire team start event storming? No. Did the entire team start? I mean, this is a team that's committed to test-driven development, and it's a small, focused team. And the camera support is, like, Dan handles the bulk of the camera support. So I think ideally you would have a team where people move around and have different areas of they are cross-functional in terms of their expertise, but that's not been so much the situation with this team, and they seem to make it work. So they all saw the impact of this in terms of the use of the feature toggles and the phase rollout and that type of thing. But I don't know, I think that's about all I could say about that one. So, I mean, sometimes as a consultant, it's coming in and making a difference in one area, but you can't always boil the ocean and change the world in a huge thing. That's why I put the starfish thing up, right? Is come in, make a difference that accrues over time would be my hope. Yeah, thank you.
Hi, I also have a question.
Yeah.
When you start refactoring, there's always the trap of, and you start moving stuff around, there's always the trap of starting to yak shave where you just think, oh, I also have to do this and this and this. Do you have any tips or ideas how you can, prevent yourself from falling into that trap?
Yes, gold plating, right? yak shaving. So I have that tendency just as much as everyone else. So it's like, oh yes, we can rename this and do this, and oh, it's lunchtime. What happened? You know, I think time boxing things and pair programming is huge for this, because when I'm driving, Dan's watching, he's thinking ahead, he's navigating, he's kind of weighing the options while I'm writing the code, and he's evaluating, and we're talking while we're doing this, and then we switch, and the process is reversed, where I'm the one kind of observing. So I think pair programming is a great way of avoiding gold plating, because your partner is a good accountability buddy for that type of thing. And Dan and I complemented each other very well in terms of our approaches, so I thought it was a good experience in that regard. Yeah, I like that.
Final question, please.
Final question.
All right. What, if anything, would you do differently the next time you're on this kind of project?
What would I do differently? Not make any mistakes, because I would have learned, hopefully, from this experience. I don't really even know how to... why did you have to ask that question? I don't know. I mean, next time I go into a project like this, I'll definitely consider feature toggles right from the start, and I'll try and take the lessons that I've learned from this and apply it to the next one. I get any sense we're out of time. I'll be available, so we can talk afterwards. I know you had a question and some others had questions, so just...
We can still have the question, that's fine.
Oh, really? Okay. 4 rows back in the middle there, right?
Stand up, please.
As you started the refactoring, you had the goal to find these early wins, or it was deliberately, or accidentally?
Well, it was a mindset of how could we make a change that would benefit not just ourselves. And so we started looking at what opportunities do we have to do that. We knew that the support team had challenges around troubleshooting people's devices, so that weighed into the decision was, well, if we could provide some back-end benefits for the support team with this, then let's give that a go. And so it was looking beyond. I think early wins is really a function of looking beyond your immediate, here's what I'm doing right now, and looking outside to the other members of the team and to other stakeholders, not even customers. Like, this wasn't customers, this was stakeholders, and seeing how could we benefit them as well with these types of changes. And as I said, they're not always there, but looking for them means that sometimes you find them, and that's a positive thing.
Paul Rayner.
All right, thank you.